and welcome to the Anomalous Review, the official podcast of the Scientific Coalition for UAP Studies, or SCU. We're an organization working to promote the serious scientific study and discussion of anomalous phenomena. My name is Michael Glosson. I'm a philosopher of science and technology, a contributing member of SCU, and the host of the show. We're glad to have you listening along, and we'd love for you to check us out at explorescu.org. If you follow the UAP field closely, you may get a sense that we're witnessing a renaissance in UAP research, a surge of serious interest that could lead to the emergence of an entirely new academic discipline. Building a new discipline from the ground up is a daunting task, though, and if we're honest, no one really knows how to do it. There's no generic blueprint to follow, and each field, whether it studies ancient Assyrian religion or migratory butterflies or the formation of stars, comprises a unique set of methods, theoretical frameworks, bodies of knowledge, and research questions. Each discipline and its constituent elements evolves in response to the specific phenomena that it studies, and, if we're honest, in response to a lot of other forces too. So, when the need for an entirely new discipline arises, how do you begin? Well, you bring together thoughtful, interested people, and start with the questions about your subject that feel most fundamental. You come up with ways of investigating these questions that seem sensible and promising. You do the investigations, you analyze your findings carefully, share your results with anyone who's interested, incorporate their feedback to generate more refined questions, and then do it all over again, ad infinitum, or at least ad nauseum. This process is exactly what the Scientific Coalition for UAP Studies is trying to help kickstart in its own research. So, at the end of 2023, a team from SCU and the University of Toronto, including scientists, historians, data analysts, and medical researchers, published a groundbreaking report. While its title may be kind of academic, it's called The Reported Shape, Size, Kinematics, Electromagnetic Effects, and Presence of Sound of UAP. Its purpose is pretty straightforward. It lays out and begins to answer some of those really fundamental feeling questions that will help establish this new field. These included questions about UAP like, what do they look like? How do they move? What colors do they display? Do they reflect or emit light? What sounds do they make? And, crucially, how do they interact with the environment and the people who observe them? To answer these questions, the team analyzed several databases containing tens of thousands of UAP reports. They focused exclusively on the most well-documented, thoroughly investigated cases, and what they discovered forms the heart of this report, drawn from the highest quality data available to us today. My guest today, Robert Powell, was one of the authors of that report, and he's here to discuss how that study worked and what its findings were. Robert brings an exceptional background to this work. He's an executive board member of the Scientific Coalition for UAP Studies, which hosts this show. He's the former director of research at the Mutual UFO Network, and he spent 3 decades in the chemical engineering and materials research fields, working in the semiconductor industry. Since dedicating himself full-time to UAP research, he's authored several influential books, including UFOs, A Scientist Explains What We Know and Don't Know, and even a book designed to introduce these concepts to young readers. I think you'll really enjoy this talk. Before we begin, though, 3 quick notes. First, you can find the complete SCU report at explorescu.org under the Publications tab, and there's also a direct link to it in our episode description. Second, in the interests of total transparency, I should say that I was one of the anonymous peer reviewers for this report before it was published, which means that the comments that I made probably had some small influence on the content of the report. I'm not sure how or if that should affect the way you listen to this conversation, but it seemed worth mentioning. Third, this conversation is slightly different than what we normally do in episodes of this show. Instead of our usual casual conversation that sort of flows wherever it wants to, Robert and I work pretty systematically through the findings of this report, and while it feels more structured, that sort of conversation lets us focus in on the details of the findings and make sure we don't miss anything. So, I want to thank Robert for bringing so much warmth to this differently structured episode than what we normally do. Now that the housekeeping is out of the way, here is my conversation with Robert Powell. Let's talk a little bit about whose idea it was, how a group got together and decided to create this, and how you started then like deciding the scope of the cases that you would look at, and then we'll kind of move from there into the actual details. So where did this
Right.
idea come from and when?
I kind of initiated the basic idea, which was let's look at reports where the object is so close to the witnesses that there's no way that they could have misidentified what they saw, or very unlikely to have
Mhm.
misidentified it, so that you're left with a situation of either it happened or they're lying, one of the
Mhm.
two. Um, so that was the impetus behind the entire idea. So then what I did, I got other individuals who were interested in doing this. So that started off with Larry Hancock, a guy by the name of Steve Purcell, and Sarah Little, and we also had a group of individuals from the University of Toronto, students
Hmm.
who helped in actually some of the drawing work that we did. So that was nice to bring them into the project.
So those illustrations are by students at the University of Toronto?
Right. I've got
Cool.
some illustrations we'll show later, and those
Mhm.
were made by students from the University of Toronto. So
That's really cool. What
that was a
department?
nice.
Like how did that come about?
This was actually driven by an individual who's over their diversity programs. So he got individuals that were in their various science departments to
Mhm.
participate in the program with us. So that was good.
That's really cool.
Yeah.
So
So what
yeah.
once we identified what we were wanting to do, then it was just a question of okay, what criteria do we want to set up front to say, okay, a case, or a report that's made must meet the following criteria to be judged as a case where the witnesses, it would be very difficult for them to have misidentified what they saw.
And what were those criteria that you initially came up with?
So that's a good question. And we started off with 100,000 potential cases,
Hmm.
right? And I'll say up front, I mean, if someone else repeats our work, we came up with 301 cases. Someone else might come up with 600
Hmm.
or 200, right? But there's a certain amount of subjectivity on the selection of those cases. But the very first requirement was that the case had been investigated, right? So it doesn't matter if let's call it a flying saucer lands in your backyard and no one came and investigated, no one interviewed you, no one verified anything. Well, we're not going to use that case.
Hmm.
So that eliminates a large number of cases right from the beginning. So it has to have been investigated. Then the second criteria was the investigation had to procure a lot of information.
Hmm.
In other words, if there's an investigation and there's not hardly any information or data, we can't use that. The third criteria was that the case normally happens in the daytime.
Hmm.
We took nighttime cases if the object was either self illuminated or something illuminated the object. So that was a criteria. The fourth criteria was how close the object is to the witness. And we didn't measure that in feet. We measured it in angular size in the sky
Hmm.
because you don't really know how far away it is, but you do know how much of the sky it takes up. So we used 0.15 degrees as the minimum size. So to give the audience a feel for that, the moon, a full moon, is 0.5
Hmm.
degrees. And on that full moon, you can see, right? You can see the eyes of the full moon. You can see the large craters, the plains. So we said, okay, if the object is at least 1/3 the size of the full moon, then we will accept that report into our database.
Hmm.
So that was our fourth criteria. The fifth criteria was that we needed multiple witnesses, or if it was a single witness, it had to be the type of witness who would have to file a report. So a police officer, a pilot, someone who's in law enforcement or the military and would have been required to file a report. So that reduces the likelihood of a hoax or anything like that.
Mm-hmm.
So once we did that and went through all these cases, and it took us, I would say, Michael, it took us about 2 years.
Wow.
And once we went, yeah, I know that was a lot
of work.
A lot of work. Once we were finished, we had 301 cases that met our criteria. And the way we did it is we had 3 individuals looking at the cases, and we would meet once every week or 2 weeks, and each of us would give a case independently, either a green, yellow, or red. And if a case if it had a single red, it was eliminated. Or if it had, let's say, 3 yellows, it was eliminated. So it had to have like 3 greens, 2 greens and a yellow, a green and a yellow, something like that, in order to make the cut.
So you're not saying then that of the 100,000 that you started with, that only 301 are genuine. You're not saying that only 301 have decent data. You're saying that you wanted to take the most reasonably stringent criteria that you could and narrow it down to the very best cases and get the sort of best analysis out of that possible.
Exactly.
So yeah. And what were those 100,000? You said that there were like 4 databases that you pulled them from. What were those databases?
Right. So we pulled them from a Project Blue Book.
Mm-hmm.
We pulled them from a database made by NICAP, which covers a time period from the 40s to about the year 2000 or so. We pulled them from, from MUFON, cases that were at MUFON. And we didn't use NUFORC because NUFORC and MUFON cases are pretty similar. The plus with MUFON cases is that a good portion had been investigated. Well, that's not the case with NUFORC cases. And that's one of our eliminating criteria, was that the case has been, investigated.
So if a person just called in and reported having seen something and nobody physically went out, like by investigate, you mean a person physically went to the location and interviewed people, or
either physically or via telephone,
interviewed
the individual.
So we had MUFON, not NUFORC, NICAP, Blue Book, and what was the 4th one?
Project Blue Book. And then the 4th one were cases that we were aware of, such as the Nimitz case from 2004, those type of cases.
Okay, so ones that weren't in a prior establishments database, but that had been
right. There were more modern cases that had happened.
And what's the scope? I think it went from the 40s to 2016 or so. Is the range of?
It went from 1947 to 2016. And I'm sorry, I forgot. We also used CUFOS cases.
Okay.
That was the organization that J. Allen Hynek founded.
So it's actually, 4 databases and then independent cases that had been investigated.
Right. Yep.
And we're running about 47, 57, 60. So it's about 70 years of cases then that were.
Right. About 100,000 cases over 70 years of time.
That's incredible. And so you narrow it down to 301. And what did you do with those cases then? You have all this data, and they're not already, I don't know how those databases are set up, but I imagine some of them break it up into a few more categories than others, but you wanted to distill your own categories out. And what were those?
Right. So we created an Excel spreadsheet, and we identified the key criteria that we wanted in that database.
Mm-hmm.
So that included everything from the shape of the object, color of the object, any type of electromagnetic interference, approximate speed of the object. We put those into buckets because it's very difficult to estimate the speed of an object. We looked at whether or not the object interacted with the witness. We looked at acceleration of the object, sudden moves, sudden increases in speed. We looked at, I'm trying to think what else. Oh, latitude, longitude of the location, of course, the exact date and time of the reported incident, the number of witnesses. Those were some of the basic, items that we looked at.
But you didn't focus this report on all of those. You picked out a smaller subset of those for this report, and then
Right.
It seemed like you're going to write a second report that focuses on the others.
We're going to write a second report where we look at time. So across the 80 years, did the percentage, for example, reports of flying disc-shaped objects, did that change over 80 years, right? And geographic locations of these 301 objects, we'll look at those. What we looked at in this report was basically just the kinematics and the shape of the object. So, what percent are triangles? What percent are spheres? Are there any more commonalities in terms of speed? Does one shape move faster than the other shape? Does one shape cause more electromagnetic interference than another shape? Right?
Now, how do you know if electromagnetic interference is even present in a case? I mean, you don't have sensors out there, so is it testing, to see if an engine shut down or something?
Right. So yeah, we defined electromagnetic interference as things such as an engine shuts down, radio interference, television or power goes off. Those were, or the jet loses communication. We had multiple cases of that, where an aircraft loses communication in the presence of a UAP. So that's what we looked at in terms of EM.
So what were the findings? Like, what sort of interesting patterns or whatever came out of the study once you got all the data sorted out and knew what you wanted to look at?
Yeah. One of the interesting ones that we were not anticipating was that triangles did not cause electromagnetic interference for whatever reason. So whenever there was EM reports, it was usually either a disc or a cylindrical shaped object, but not a triangle. And that was something that came out that we weren't expecting, right? We kind of would have expected it more just to be random. Sometimes it's this shape, sometimes it's that shape. But there was definitely a relationship between shape and electromagnetic interference.
What does that do for your underlying theory? Like, I guess when we go in, we say that maybe we want to assume the simplest explanation, whatever that means, but that would probably mean that, like, well, they're all kind of operating on the same principles. But if they're just like cars, cars can have different shapes, but they all have a combustion engine or now like an electric motor or something. But that kind of changes that, right? I mean, is that the assumption that or the conclusion that you draw, that they're being propelled in different ways?
We didn't draw any conclusions around that in the paper, but
sure.
We thought about it, right? And I mean, I thought about it personally, and not just in this paper, just in my study of this subject for the last 17 years. It tends to indicate, it's not proof, but tends to indicate that, for example, the triangle has a different propulsion mechanism, perhaps, than a disc-shaped object. I mean, if you look at our own type of craft, right, they're basically all some type of, like you said, combustible engine. So they're all going to have hydrocarbon emissions. Although now, today, as we've moved more into the electrical world, we have some vehicles that will not have a hydrocarbon emission, like a electrical drone. But so it's possible you can have, distinct characteristics with the same craft, but it's more of a gut feel of mine that whatever the source is of these craft, it's not all the same source. Is my
Oh,
I would
whatever the source,
that's
their origin, like whatever's creating
the
them.
origin. Yeah,
Oh,
I would
interesting.
say the
That's
origin's not the same if I had to guess, but it's not something that I would put in a paper,
sure.
right? Because I can't prove that. There's no way I can prove it one way or the other. But that is, it's more of a gut instinct.
Hmm. So it's sort of like if you saw a helicopter versus you saw, well, maybe not a helicopter, but if you saw a pontoon boat versus like a nuclear sub, you would say those were built in different factor. I
Yeah,
mean, very
yeah,
different kind of.
those are have came from different locations or not from the same source.
Yeah.
That would be my instinct.
So when you look at, let's focus on electromagnetic effects for a second. So in some of these cases, television shut down, communications go out, lights flicker, engines die. What what sort of inferences can you draw that aren't speculation, but just about like what sort of object or technology would do that? What sort of level of power would it have to be working at or something? Like, can we make those sorts of inferences?
Well, I think you can. You cannot infer, of course, whether it's intentional or
Hmm.
it is just a result of a propulsion system, right? Uh, I what I would infer is that whatever is causing it is a strong electromagnetic field that's interfering with the operation of a radio or a television or an automobile. Uh, is to the amount of power required to do that really depends on the distance of the object
Hmm.
uh, to the witness. Um, each case is different, right? It's how that electrical, how the radio is put together. Um, for example, the case of a barbell situation where we have a gentleman who he had three pieces of electrical equipment fail in three different manners. He had a Motorola field radio, which the wiring burned out. He had a Motorola phone, which basically just went into a boot up mode
Hmm.
when in the presence. And then he had a video camera, which basically, as soon as you turned it on, it turned itself off, right? So, like in the latter case, there's probably some type of circuitry in that Sony camera that protects the circuit. And if it's in the presence of a field that's inducing current into its circuit, it probably turns itself off to
Hmm.
prevent damage. So you can't always draw a conclusion based on what each of those given pieces of equipment are doing until you analyze in detail that particular, equipment.
So that
Uh,
it still seems like you would need an immensely powerful electromagnet or something generating an electromagnetic field to have those sorts of effects at any distance, greater than like your arm or something. Because I mean,
right,
like an MRI generates an enormous electromagnetic field, but you have to be right in the middle of the sort of torus
right,
donut shaped
yeah,
thing that does it. And like magnetic fields dissipated like a logarithmically over distance. So the further you get away, it just gets exponentially weaker and weaker. So it would have to be
yep,
something extraordinarily powerful.
right, and it's some of the reports you can't really uh, would be difficult to explain, right? For example, the 1970, I believe it's 74, 76 case in Tehran, Iran,
Hmm.
right, where you have a jet fighter and he's moving towards this UAP and he loses all of his communications and weapons control. But he doesn't lose the ability to control his jet.
Hmm. Hmm.
Otherwise, right? So, like for us, if we were to put an EM pulse on that jet,
They just shut
it,
everything
it would
down.
just shuts everything down. You can't just shut pieces of it down. So, if what the pilot says is true, that's some technology we don't have to be able to selectively shut down particular pieces of equipment and at extreme distance.
Is that something you look at in these cases where you see some electromagnetic effect, but it's more particular or seems more targeted or selective than you would have expected? Like if a person says, my television shut down, I guess in this report you can't ask because you're not actually doing the investigations, but it seems like one could ask when they're looking at these reports, well, what else shut down and what would we have expected to, and whether other electronics were in the room. That might be an interesting study, but I'm sure you can't do it just off of the databases.
Right, right. We can't really do that off the database. That's really where you need to have a equipment there at the time the event occurs so that you can
Mm-hmm.
take lots of measurements because there's just not enough science in the reports to be able to draw any strong conclusions on that. The other thing that I could talk about, Michael, that you brought up, besides EM, would be the shape of these
Please.
objects.
Yeah.
So I could maybe if I could share my screen.
Yeah.
So this shape was what? Let me back up a little bit. These shapes we only did this work to create a shape if there were enough reports in those 301 to make sense of doing that. So, for
Mm-hmm.
example, the the barbell type shape or the tic tac shape or any of those, there just weren't enough reports to say, okay, over time, this is the shape that's normally reported.
Mm-hmm.
This one was. This is the dome disc, and across all discs, about 301 shapes, we had about 110 shapes that were some form of a disc.
Hmm.
The dome disc, this was usually the size 8 to 16 feet in height, 20 to 40 in diameter, and the ratio was 2.5 to 1.
Hmm.
And what's interesting about that is that the Battelle report, which looked at the U.S. Air Force's cases back in 1955, they came out with this same shape, except they had a ratio of 3 to 1.
Hmm. But
And
pretty
their
close.
size, yeah, very close. And their size range was 20 to 30 feet.
Yeah.
So it's, what it makes you think about is, well, why over time do people continue to report the same ratios and sizes,
Yeah.
right? You'd think it would just vary instead of being consistent like that.
Yeah. I mean, especially if these were misapprehensions of something. I mean, I guess unless they were misapprehensions of the exact same thing over time.
Yeah.
But it's hard to see
And
how you'd get that.
this shape, which was one of the more common shapes,
It's like a
is
football sort of shape.
right. It's football shape, 3-1 ratio. This one does not have a dome, and it's usually a little bit larger, 30 to 60 feet, and about 10 to 20 feet. But the ratio is very similar.
Mm-hmm.
Now, this next one's really interesting.
Hmm.
The ratio of the disc when it's 7 to 1, approximately. So, it could have been 6 to 1, 8 to 1,
So
but the
an
range of
extremely
7 to 1,
elongated football, like a
right?
stretched out football, very long.
Very elongated. When that happens, it's a much larger object.
Mm-hmm.
So it's like there's two distinct types of discs. You have the large one, which is 7-to-1 ratio, and the small one, which is a 3-to-1. But you know what you would expect to see, right? If this is all random, is you would expect the large one to be 3-to-1 and the small one to be 3-to-1. But that's not what we see. So this is very interesting. And then, of course, after the disc, the most common shape is the triangle. And this, of all shapes, the equilateral triangle is the most repeated description of the shapes. And when I say that, it's almost always 100 to 150 feet up per side. There's always these very large globes near the apex of the triangle, and they're usually large, 6 feet in size, usually white in color. And then there's usually a red light in the very center. So it's just very amazing. Specific. Yeah, very specific, right? It's like, how do all these witnesses keep describing the exact same thing? And of course, the triangle has been more prevalent since the 1970s. Is when it, although it's been reported as far back as 1950s, but that's the other reason that it makes me think of a different source, because not only does this triangle not have cause EM interference, but it was not as prevalent back in the 1940s, 50s, and 60s as the disc was. And then the last is a isosceles type triangle. Again, a large object. And what's usually unique on this is that witnesses describe a multitude of colors on it. So, and some people even call it, well, it was like a Christmas tree.
And this one's enormous. This is between 200 and 300 feet long. So it would take up a football field.
Right. And so it's very large. And so the equilateral, which we just saw, was about 150 feet inside. So if you see my cursor here, it would be more of like, you just cut this guy off a little bit. So these are usually reported quite a bit larger than the equilateral triangle.
Now, all the triangles you're showing them oriented sort of vertically. Do you get a sense from the reports of, I assume they're flying horizontally, that people are seeing them from the underside. Do you get a sense of how thick they are, how tall?
Yeah, these, what I showed you, are just the top views. We drew side views of these also. And the side, the thickness of them is usually in the range of 15 feet. So actually, considering the size, it's not that thick.
So they do seem like they could be craft. I mean, they're reasonably large enough that people could walk around in them of like a normal human size or something. But they don't, at least in the report, you talk about shape, but it doesn't seem like you go very far into talking about like surface features, whether they had doors or windows on them. That doesn't seem like the main focus. But do you have a sense of how common that is?
That's not very common. Usually the object's described as just a perfect piece of metal. And there's rarely descriptions of windows, rivets, hinges, of, how we normally create a craft, right? You've got all these parts that go together. There's usually none of that. It's usually just the shape that you see.
One of the kinds of reports that I've seen a few of, just reading like Hynek's book and a few others, that really intrigues me is when people describe an object, but they can't describe the color of it or the shape of it because it sort of is not apprehendable to them, or maybe it changes shape. Is that something you had to exclude from this if a person said they saw an object that started out as like one sphere and turned into three, or changed its general form or something? How do you deal with that?
We didn't really have any of those type,
Mhm.
for whatever reason. Because I have seen those type reports, right? So either it got eliminated because it was too far away, or there weren't sufficient number of witnesses, or it wasn't a pilot that reported it, or it wasn't fully investigated.
Hmm.
Yeah. But I think of our 301 cases, none of them were a shape changing type incident.
I guess it'd also be hard to distinguish those from a case in which the observational conditions just didn't seem good enough. Like, how do you know whether something actually changed shape, or if a person just said, "Oh, I couldn't really see it well enough to know what its shape or color
Yeah,
or something was."
right. Because when it's at far distance, right, uh, the appearance of a changing shape could just be due to the observer and
Mm-hmm.
the object, not being clear and at far distance.
So
Um,
do you feel like you came out of this study with something more like a taxonomy of the kinds of craft there are that we can use going forward to say, oh, well, it's this kind and that kind. So we've got like disc types and triangle types. Are there subtypes of those, or what's the taxonomy you're working with so far?
yeah, I mean, the main taxonomy that we worked with were the disc with the dome,
Mhm.
and then the two different non-dome discs that had different ratios, 3-1, 7-1, and then the two types of triangles. Now there were smaller cases of spheres,
Mhm.
right? Which, if you look at the Arrow report today, they make that as their majority case. But the way our cases were developed, a tiny sphere at far distance would not make our list,
Mhm.
right? Because it's too small, too far away. And that's spheres are actually very common because that's when an object's far away, that's often what you see is just a sphere.
It just blurs into a
Um,
dot. That's what blurring
right.
is. Yeah.
But the other shapes that we didn't have enough to feel like we could add them to the taxonomy, although I think if we did further work, brought in more cases, we would have enough to do it. One would be the tic tac,
Mhm.
because we had 3 tic tac cases and they were very consistent, and that they're pretty much like what Commander Fravor had described as a tic tac, an object 30 to 60 feet in length, that looks like a pill. And in some reports, they called it a propane tank. It was
Mm-hmm.
a flying propane tank. Uh, so that I think is a definite shape that's out there. And then the cylinder. Um, the one problem with the cylinder is that if you see the disc, from a side view and don't see it from any other angle, it may look like a
Sure.
cylinder.
Yeah.
Um,
And a disc could
so,
look like a sphere if you saw it from sort of orthogonally
right.
or whatever.
Yep. Yep.
Yeah.
The disc, if you see it just straight up above, as a matter of fact, one of the cases that's in our database, is the Chicago O'Hare case.
The airport
And
case,
yeah, and there
2006.
was a witness, and I actually did this report. It came in after the bulk of the Chicago O'Hare
Mhm.
witnesses. This is the only witness that we know of who was on an aircraft
Mm.
landing at Chicago O'Hare and saw the object as he was landing. And he actually described exactly what you're talking about. As the plane was coming in for a landing and he saw the disc from above, he said it looked like a sphere,
Mhm.
right? Because he's just looking at the top of
Straight
the
down at it.
disc.
Yeah.
But he said, as the plane dropped below the disc and he saw it sideways, he could tell it was a disc at that point.
So then, so we've got these big groups, the big clumpy groups that you can come out with from these 301 cases, and you said about a third of them are discs of some sort with domes or without domes, and
Right.
then the other two-thirds are triangles. How would you break up the percentages?
Well, I think 110 if I remember right from memory, were disc shapes. I think the triangle was probably 50 to 60 cases, somewhere in there. I'd have to look up the exact number. And the remainder were just miscellaneous different type
Barbells and
shapes.
pills.
Well, for example, one was what the witnesses called a ovoid,
Mm-hmm.
right? Which could be a disc,
Mm-hmm.
right? Except that they call it an ovoid, and they didn't give the disc ratios, so we couldn't necessarily qualify it as a disc. And then you had the cylinder type shapes. You had some tic tacs. There were some shapes unique that were boomerangs, right? And we separated the boomerangs away from the triangles. And then there was the delta shape. That was or chevron.
Mm-hmm.
Those were a number of those. There were some plasmas, and we only accepted a plasma because it was close enough to the witness that we were confident that's what they were looking at, and those. But there weren't enough that we could put that in the taxonomy,
Mm-hmm.
right? But if you go back, I mean, if you just study the topic overall, that's kind of what the Foo Fighters were. They
They're
were
just
mostly,
luminous orbs of some sort.
yeah, luminous orbs that move through the sky. But because of the way we selected cases, we would tend to eliminate those type cases most of the time because there's not a real feature that's easy to identify.
So then what patterns start emerging? Like, you said that you saw EM effects for the triangles. Do you see differences in like how they move that give you any idea of what's going on in these objects?
Yeah, one of the patterns that's interesting was the lack of sound, right? And so probably most people have heard, okay, witnesses that talked about, I didn't hear anything.
Mm-hmm.
But what's unique is it's not just the witness says, I didn't hear anything. It's that the witness says, it was close enough to me that I should have heard something,
Sure.
and I didn't. So, that's really different from just saying I didn't hear anything. When you say, it was so close, there's no way I couldn't have heard it, but I didn't. And there were a number of cases of that where there's just no sound at all. I mean, that existed with the triangles, and it existed with the disc-shaped objects as well.
And that's different from just saying it moved so fast that you would have expected to hear a propeller or a jet burning or something. You're saying
Right.
that they got close enough to the object that they felt in their own little like sphere of sound, they should have heard it doing something, and then there's nothing.
Right. Yeah. Because, the witness is expecting to hear what they would hear from a helicopter or an aircraft or, something like that. And they're not hearing anything.
Were there ever sound effects reported?
Yeah. Now, there were some, especially with the cylinders and sometimes with the dome-shaped discs. And sometimes there were distinct sounds that were heard, such as it sounded like a rattling washing machine, right? Which is kind of strange.
Yeah.
And with the triangle, the sound that sometimes heard was like a hum. And sometimes people would describe it as an electrical type of a hum.
Crackly or
and then, yeah. And then sometimes you would hear someone that might describe it as a sound that you could just feel in your chest, right? Mm-hmm. So that indicates it's probably a very low frequency
infrasound or something. Yeah.
Yeah.
Huh. But the rattling washing machine, it's like, it reminds me of this class of case. There's like, you can find enough reports that I think it's a thing of like objects over the ocean that are spitting out molten metal and then just like fly off really quickly. I wonder if there's something wrong with the rattling washing machine cases.
Yeah.
What is your sense coming away from, the patterns that you see? So your sense is that the triangles are made differently, that maybe they operate on some different principle of propulsion. Do you get the sense of what sort of systems are involved in the different kinds, or like one is using EM in some way? I don't even know how EM propulsion would work in this case. Or what do you
Yeah,
think?
I I don't have a from the study we did. I don't have a good feel for their propulsion mechanism, right? Other than the signature of high acceleration.
Mhm.
And so with high acceleration, that's more than just saying we eliminated gravity,
Mhm.
right? Because I can I can take our most powerful rockets and just magically put them into space so they don't have to overcome Earth's gravity, ignite them, and you still don't have extreme acceleration,
Hmm.
right? That's something else when you get that. And the way we would uh, look for extreme acceleration in the report would be, for example, a witness that sees an object. So imagine you see an object, let's say the size of the full moon,
Okay.
and you're watching it. It begins to move away. Within 2 seconds, it's disappeared. Well, you can you can do some rough calculations on the type of acceleration that's required to make an object. Doesn't matter how far away or right, because you're the farther away it is, then the bigger it is,
Hmm.
because we're talking about angular size. The closer it is, the smaller it is. But for it to disappear from view within 2 seconds requires an extreme amount of acceleration.
Hmm.
To give you an example, if you were looking at an F-18 and he was about the size of the full moon, and let's just say he was cruising 250 miles an hour, and he turns on his afterburners and starts to accelerate. Well, it will be 13 seconds before he's disappeared from your sight, as long as you've got a clear view of the jet. So to disappear in 2 seconds requires extreme acceleration.
So if it were the size of an F-18, which is like 56 feet or something in length,
Yeah,
what sort of acceleration would that need to get out of completely out of view in 2 seconds?
I would have to look, at a specific case, but we
Hmm.
kind of looked at that when we looked at the 2004 Nimitz event.
Hmm.
And if I remember right, it would require something like 100 G forces of speed increase to disappear within 2 seconds.
Which
So it's
we don't have anything that, at least nothing that carries humans that goes 100.
right. And then additionally, with the speeds you would reach within those 2 seconds, there should be atmospheric interaction, right? So there should have been a sonic boom. The object should have begun to glow from friction with the atmosphere, right? And if you were anywhere near it, you should have felt the wind as the object began to move. But in all these reports, we don't see that. So they all
None.
tend
You
to
never see
indicate.
a sonic boom ever.
I can't think of a single case I've heard where they said, yeah, this object took off and I heard the sonic boom.
Yeah,
And
I can't either. That's interesting.
I can't think of one where someone said, well, the UFO was here. He started accelerating and he turned red hot.
Mm.
He glowed red hot as he was disappearing. Never hear that. Or he was streaking across the sky and there was, the heat. You could see the heat coming off of the UFO. Now, you do hear sometimes of of kind of a wavy appearance
Mm.
around them, right?
Which
Kind
could
of
be
like on
heat
a hot
or
summer day, right? Could be heat, or it could be, the refractive index of the air around it's hard to say. Um,
that effect can
but
also
you
be
don't.
caused electromagnetically, can it?
I'm not sure if that can. I mean, it could be if you had an electromagnetic field strong enough to start to excite the air molecules around an object, right?
Maybe I'm thinking it
Create
can
like a
also do it to
plasma.
cameras. I think there are electromagnetic fields that can cause camera to have like a wave. I think they're called Dyson rings, or not Dyson. Oh yeah, after Freeman Dyson, maybe. Yeah, a sort of waviness. Maybe it's only in cameras, that maybe it's not visible to optical. So, but in those cases, you would think that the waviness is because it's putting off heat, or do you have ever have like since cases where you're seeing it through FLIR or infrared and you do see a huge heat signature? Do they ever have heat signatures that you expect?
Um, I mean, this is not one of our 301 cases,
Hmm.
but I can only think offhand of one case where there was an extreme heat signature uh, by the UFO or the UAP, and that was a Coast Guard case where they were looking down at an object that they thought was in the water or on the surface of the water,
Hmm.
and they thought it was a ship on fire because their IR was indicating hundreds of degrees of heat. So that was their impression. But then when the object made a 90-degree turn, they knew it wasn't a ship anymore.
Hmm.
And then it took off and moved up into the atmosphere. So then for sure it wasn't a ship. But that's the only one I can think of where there was extreme heat in the eye, in the infrared.
It's just so bizarre that you would have these patterns. I mean, if you try your hardest to assume that there are prosaic explanations for all of these, you just would not expect anything like these patterns of people saying that there's no contrail left behind. There's no like sound of turbulence. I mean, like a plane produces an enormous amount of sound just from the wind moving against its surface, and they're pretty aerodynamic. I mean, if something's flying over
Yeah.
your head really fast, you should hear it.
Well, even a B-2, the B-2 bomber, right, which is designed to be as quiet as possible. I was in a military operating area and a B-2 went by, and I don't know, he was probably a mile away. I could hear him without a problem.
Mhm.
He wasn't as loud as like an F-16 or something else, but you could definitely hear the plane as it went by.
So they should make some sound, and that's not, is that the engine making that sound, or is it mostly just the turbulence from the
I think
interference
it's
with the
mostly
atmosphere?
the engine that makes most of the sound.
Okay. So you're not having engine sounds, you're not having wind generated, you don't see, vortices. I guess you do see them punch through clouds sometimes, though. So that seems like a kind of interference with the interaction with the atmosphere that is present.
Yeah, yeah. I mean, that is a good example of interaction with the atmosphere when you see these holes punched through the clouds. And there's the Chicago O'Hare case
Hmm.
is one where that happened. And I think there's one or two others where
Yeah.
that's been reported to have happened.
So then let's speculate. What sort of technology would punch a hole through a cloud if it moved there, but wouldn't create any wind noise or friction with the atmosphere?
Um, I don't know. Maybe if you somehow there was a field, some type of field around the craft as it's moving.
Hmm.
Uh, as you look at it moving through the regular atmosphere, you wouldn't see anything because you can't see the field.
Hmm.
But if the field affects whatever's around it, then if you go through a foggy area or a thick cloud, then you would it could probably move the
Those
cloud
particles out of the way.
parts.
Yeah,
Yeah, so that you can see that, and you can't see it when it's just moving regular air particles
sure.
away from it.
And it might do it without a lot of resistance, but it would still move those particles.
Yeah.
What kind of propulsion then are these like is it anti-gravity or is it
Like I
what
said,
is it?
anti-gravity doesn't explain the acceleration.
Hmm.
My my favorite, but we don't have there's no scientific evidence of this yet. And that's the concept that like that the inertial mass of my phone here could be reduced
Hmm.
so that I could drive the inertial mass towards zero. So if you could do that, which we haven't proven that you can, then I could accelerate this cell phone near the speed of light, right? All I'd have to do is have a few photons impact it. And if there was no atmosphere here
It would take
to
like zero
resist it,
energy almost.
right, it'd take basically zero energy. So the photons would impart their speed to this full cell phone, and it would move at speed of light. But that, so if you had that capability, then you could have an instant acceleration. And the question is how, if somehow there's a field around this that's causing that, then you're going to have, and I'm just guessing here, but if you assume that field drops off the inverse square, just like a magnetic field or anything else, then this low inertial mass may affect the atmosphere around it too. Right. So now as I'm moving through the clouds around this craft now suddenly lose some of their inertial mass. So now they may begin to move because they don't weigh the same as they would normally have weighed. So that's, I've wondered about that, just like in the instance of Fravor, right? When they see that tic tac and they see the broiling water,
the water churning underneath it. Yeah.
Right. So is there really something under the water, or is that possibly just the effect of, let's say, if the tic tac is able to lower the inertial mass of itself and everything around it, then is the surface of the water close enough to the tic tac that it's lost enough inertial mass so that now the surface of your water weighs less than the bulk of the
water
ocean
beneath it. Yeah.
Yeah.
So it'd be
and so now you
constantly
start
moving
getting
out of
this
its way.
churning.
Yeah.
A churning effect. Just kind of like when you pour a heavy liquid into a light liquid, or a light liquid into a heavy liquid.
So is that your, if you had to place your money on it, is that where you would bet how these things are operating?
If I had to, if I had to place my money, then I would bet that that's what I would say, is that they're capable of reducing their mass to zero, right? And then if you can do that, you don't have to worry about inertia anymore, right? And you don't have to worry about that acceleration because we don't know that there's a living being in these objects, but let's just assume there was. If I'm in the object and my inertial mass has dropped, well, that acceleration doesn't affect me.
Yeah, you don't have to worry about it.
Yeah, don't have to
50,000 G's or whatever. It doesn't really matter.
No problem, because I don't have any weight.
So on that theory, what happens if I just drive it into the side of a mountain? I mean, do solid objects resist something that has no inertial mass?
Well, I guess that becomes a question of if I reduce my mass towards zero, how close to zero can I get? I mean, if I can get like a neutrino, right? He's got an inertial mass that's just about as close to zero as you can get. He can go right through the mountain. But if I can't quite get there, I may have a problem when I hit the mountain.
Okay, so even if you could go into the mountain, I mean, if you've got a very, very low inertial mass, but it's not zero, you might be able to pass through the mountain, but it could ruin your DNA or like
or it might not get all the way through.
Oh, okay. Be stuck inside the mountain. That's interesting. Would that explain how some of these objects seem able to? I know this is not in the study, so we're going outside the mountains.
Right. We're outside of the study.
But some of these objects can pass through water. It seems pretty as if it doesn't even matter. Would that sort of propulsion explain that ability, that transmedium ability?
Yeah, because I guess if you don't have any mass and you're impacting the water, which just purely from chemistry in terms, in physics terms, there's not a whole lot a, a difference between the density of air and the density of water as compared to the density of that mountain.
Sure.
That's a, a real big jump. But so I could see how an object that had very little inertial mass could just go straight into the water with very little movement of the water, maybe none. And it would be able to move through the water, at a very high speed.
So the water's just moving out of its way because it's a fluid. The air is a fluid, right? It's all kind of churning constantly. You've got something with almost no mass passing around. It's not going to create any resistance or real friction or anything. Oh.
Yeah, it's I guess you'd have to model it somehow.
Mhm.
Um, is exactly what happens as you're moving through the atmosphere, for example, or through the water, because the object itself, let's say, is close to zero inertial mass. But what happens to the atmosphere immediately around it,
Mhm.
right? Uh, my guess would be its inertial mass has been reduced also, and it's probably a gradient that moves
Mhm.
away from the object. Um, so at some point, it seems like you should have some resistance somewhere. Um,
Yeah,
but
but it
I don't
might be
know, maybe not.
the it might be that there is you are creating existent resistance, but you're sort of offloading it to the particles around you in that gradient, right? There's some
Yeah,
friction, but it's
yeah,
really between these particles out here. It's not, I don't have anything to do with that, right? That friction's out there and it's fine. Um,
yeah,
but you could still move your thing, whatever's at the center of this field could still move pretty well. But I guess if whatever's generating that field shut down while you're moving, you'd be in real trouble, right? If you're moving at
yeah,
like
yeah,
50,000 Gs or whatever it is,
yeah. Then I would think you should immediately be interacting with the atmosphere, and
you just combust, right? I mean,
yeah,
yeah.
which is which is what we should expect should happen, right? Just like a meteorite coming into
Yeah.
the atmosphere, there should be instant combustion. Uh, there's 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 no explanation for an object that could move 30,000 miles an hour through the atmosphere without combusting.
Seems like a risky form of travel. Like if my engine shuts down on the car, shuts down on the road, I'm in. It's a real inconvenience, but I don't like instantly die. That seems like the risk of traveling using a technology like that. If you're traveling through an atmosphere, I guess, but if you're in space, it wouldn't matter. I guess
No,
this would also solve problems like if you're using these things to travel interstellar distances. One of the problems of interstellar travel, or at least like very fast travel, is that there's not much out in space, but if you hit a piece of dust going really, really fast, it could be catastrophic. Does this
right?
solve that
Yeah,
problem too, I guess?
right. And not only that, even without there's enough hydrogen atoms in space that if you're traveling near light speeds, that your spaceship's going to be heating up
Mm,
from the because if you think about it, you're just piling these hydrogen atoms that are in space uh, on the front of your spaceship as you're
hmm.
traveling through at this extreme speed. But if your mass, if the mass of your spaceship is driven towards zero, then it's not an issue as much anymore.
Would there be any limits to this sort of to the acceleration that you could perform? I guess the instant acceleration. You couldn't go faster than the speed of light, but you could, I guess, conceivably, if there's no resistance, you could go any speed you want below that instantaneously.
I would think so, pretty much. I mean, it's just driven by how close to zero can you drive your inertial
Hmm.
mass. And again, I should note to the audience, there's been no evidence yet in
Yeah,
science
it's
that we're
pure
capable of
speculation.
changing the inertial mass of an object. As a matter of fact, there's you can argue whether there's a difference between inertial mass and the object's real mass, because if you can't drive it toward, if you can't change inertial mass, then you know it's hard to define what inertial mass is other
Yeah,
than just mass.
but that. It seems like the problem with studies like this is that inevitably they push you into territory of speculate. And when we do studies, we don't want to speculate. We want to look at data and we want to draw whatever conclusions we can. But when the conclusion is that there are objects that can accelerate impossibly, given our like current understanding of how physics works, it seems like these studies inevitably pull you into speculation of some sort. I mean, what else can you do other than say, well, there are things that can't happen, but they are happening?
Well, yeah, because if you are dealing with a technology that's hundreds of years more advanced than ours, I mean, how do you explain it? I mean, how would Leonardo da Vinci explain how the cell phone works? Uh, I mean, part of the way it works is because electrons tunnel through a thin oxide with and somehow appear on the other side. We don't even really know exactly how that happens, other than we know it happens. We know how to make it happen. But like Da Vinci, he
have the
would have,
concept of an electron.
yeah. So how can he explain how it works?
So then does that make you think?
And that doesn't mean that we've broken the laws of physics, right?
No, sure, of course.
Da Vinci might think we've broken the laws of physics, but we haven't really. Same thing for the UAP. We may think that they've broken the law of physics, but I don't think, I think the laws of physics are what they are. And
so do you think so if we went back to the question of where you put your money, and I gave you a different option, you can put your money on this sort of, they drive their inertial mass down to zero technology, or you can put your money on the explanation that there is some form of technology or physics for which we don't even have the concepts, in the way that like Leonardo da Vinci does not have the concepts of an electron or whatever. Which of those two would you say?
Well, if I'm going to put my money, I'm going to put it on the latter,
yeah,
right? But then that it's some concept I just have no understanding. But then if I put my money on the latter, then we can't really discuss it because we don't know what we're talking about. So I have to put, initially, when you ask me that, I put the money on something I can at least discuss.
Yeah, I mean, of the theories that we can come up with, that's the one that you want to like put your money
right
on. But
yeah,
probably maybe there's just whatever theory is going to be right is going to require a whole set of concepts that we're not working with.
Yeah, I think that's the most likely.
I do too. And when I was reading this study, one of the sort of speculative questions that I came up with was, why are we looking at the particular features that this study looks at? And I think it was size, shape, kinematics, electromagnetic effects, and sound emanations. Those were the things. And I thought, well, why are we selecting those rather than others? Not that I think there's a problem with that, but it seems to me that the kind of intuitive guiding principle was the idea that these are craft. They're like cars, kind of, or planes or something. And those are the features that we know can help us identify what sort of object, what sort of craft we're looking at. But why then don't we look at things like whether a person experienced some deep emotional response to it?
Right.
Well, because planes don't do that, But if these are totally different, if these technologies work on some principles that we don't even understand, they might not obey the distinctions between technology and emotion and all those other things that we see as distinct. Does that make any sense?
No, yeah, it does. And that's actually a pretty good question, Michael, because the reason we chose those is because what we're trying to do is we're trying to help people who want to build scientific instruments, right, to go look at these objects, right? So if we have some basis of what type of equipment they should be looking at based on what we've seen from, human eyes, and to a certain extent, maybe occasional radar data, we can say, all right, here's the shapes that your software should be kind of looking towards. You should have some type of acoustical sound equipment, right, to verify that there was no sound, right?
Hmm.
When you're visually grabbed a picture of this object, and you should have equipment that can measure electromagnetic fields, right? Also, when you're trying to develop systems to measure this. So it's to try to help the next step in science, which is to go get the actual measurements with sophisticated equipment, and and so that's kind of why we looked at those.
Hmm.
But still, your question of, well, yeah, but how does it affect the individual? And see, that's something that's a little harder to measure.
Sure.
I'm not sure uh, what type of equipment we're going to put out there to measure that. Um, but I feel at the same time we shouldn't ignore it,
Hmm.
right? If it truly affects the observer, and the observer's running the equipment that's taking the measurements, well, it's good to know that it's affects the observer in some manner.
Yeah. But I mean, we don't have even in psychology, we don't have really well established like standard instruments for measuring things. Even like questionnaires are haven't in the last 30 years become standard. Oh, only in the last 30 years or so become like standard instruments for, you know, asking people questions about what sort of a psychological effects an experience might have had. Like, even if we wanted to collect the data, it might not be available to us. But I keep coming back in my mind whenever I read about these things to this idea that if it's technology we don't understand, and physics we don't understand, and principles of how the universe works that we don't understand, then our assumptions about how to study it are going to be wrong in some way, or they're going to be incomplete. Not wrong in like the sense that they're
Yeah,
contrary, but there's going to be some incomplete part to this. And how do you study a phenomenon that operates outside the bounds of the way you believe the world works? Like, what do you look for, and how would you know if the effects were there when you don't know to look for them?
right, right. So I think that's a key issue. So it's like, how do you, especially how do you study something that has intelligent control,
Hmm.
right? If there's intelligence involved, how do you study it? I mean, in physics and chemistry, right, it's real straightforward, right? I mix sodium bicarbonate and acetic acid, and I can repeatedly get the same reaction. I study bacteria, and I can pretty much, you know, this temperature, these nutrients, this is how the bacteria will
Hmm.
react. Now I start to study a pack of dogs. It's not so clear cut, right? I may not be able to repeat what the last experimenter did. And now, if you start dealing with humans, right, psychology and sociology, it it's even harder, because that what you're studying has the ability to affect your measurements and your testing,
Hmm.
right? And so imagine, what if you're trying to study something that's more intelligent than you are? I mean, talk about a soft science. That's going to get really soft.
Yeah. I mean, there's sort of loops of kind of feedback problems that you have. Like, if you're studying something that's more intelligent than you and it knows that you're studying it,
Yeah,
how can you ever believe your results? Because especially if you don't know its intentions, right, it might want you to draw certain conclusions. And if it has the power to make you draw those conclusions, how could you ever believe anything other than this is the set of conclusions it wanted me or allowed me to draw about it? And I wonder about this too, but it seems like the study of UAP almost has to operate on the assumption that these are like,
I need a key.
uh, oop, I think you got,
Sir. Oh,
that's
sorry,
okay.
Michael.
We'll edit. Hey,
Yeah, she's already
I
gone.
don't think she saw me. Um,
Uh,
but it seems like the study of UAP has to operate on this assumption that these are just basically like fancy cars that can fly in some way we don't understand. And because if you assume that they're anything else, then you don't know what exactly to look for. Like, it's at least plausible, I think, that 10,000 years from now, our distinctions between like psychology and technology will just completely break down. And we'll have some understanding of consciousness that makes, machines conscious and emotional or something, and we'll have some form of propulsion that has to be conscious in order for it to work or something. I mean, those are possibilities, right? Science and technology have evolved in ways that have broken down past conceptions in very similar ways. But if that's the case, if that's the sort of thing we're looking at, for instance, we have no idea how to study it correctly, and we can't study it correctly because it just doesn't, it won't ever fit our our preconceptions. And it seems like we run against that sometimes with like the Tic Tac case. Like, we can describe its shape and its kinematics, but then it exhibits other behaviors, like it flew to a rendezvous point ahead of people going there when that was a secret location that hadn't been communicated. But then we have to place that behavior sort of outside of its kinematics because it implies knowledge or foresight or will or something that we can't
Yeah.
really account for. There's not a
Yeah,
question
no,
there, it's
that's
just a point there.
right. No, it's a very valid point. And it's the same thing if we're dealing with a aircraft, for example, that's from another nation.
Mm-hmm.
I mean, there's a pilot in there, and he very well may know that we're, for example, he has equipment that can detect that we have just sent a radar signal to his plane to detect his location. And so he knows that we just did that and where we're located,
Mm-hmm.
that sent the radar signal. And that's just, you know, common
The
human.
technology we have now, yeah,
Yeah.
you know that.
It's hard to fathom if you're dealing with an intelligence greater than yourself, what its capabilities are.
So when you're looking at the data that we do have, going back to the report, do you, how to phrase this? We want to know not just what these things can do, like what sort of acceleration profiles they can have. We want to know, like, fundamentally what they are. And we have to make some assumptions. We have to start with assumptions that are we're familiar with, that they're like planes in a certain way, but they're not like planes in other ways. Um, how far do you think it's reasonable to infer when it comes to questions like what's on the inside of these things? Do they have an interior that has like beings inside of it? Can we use its shape or its dimensions or its acceleration to answer those questions, or what their intentions are? Are they sensing things, or are they observing in a sort of visual way? Where do you go with questions like that from data like this?
Yeah, I don't think we can conclude, what's inside them. I mean, they could be completely drone based, right? Or there could be a living organism inside, or it could be a automon type of,
Hmm.
robotic organism that's inside it. I don't think there's any way we can draw a conclusion, one way or another on that.
Well, can't you at least draw negative conclusions? Like, none of them seem to have appendages. So they're not trying to physically, mechanically interact with the environment. So that kind of like seems to narrow down what they might be doing, right? Like, if they must be sensing or something, right? That it seems like that's kind of a go-to assumption, is that they're observing, or they have some intent where they are, but that we can at least like knock out certain possible intentions. Do you have a sense of how, like, where we go in that direction?
Um, well, we do have some projects in SCU where we kind of looked at intent, in terms of nuclear facilities.
Hmm.
So there does seem to be, I mean, because like I was asked once if I could do anything I wanted, had unlimited funds to go look for one of these, what would I do? And I said, well, I would have a scientific research ship that just followed U.S. carrier strike forces around the
Hmm.
ocean, because our nuclear powered carriers seem to
Be of interest.
attract UAP reports. So Uh,
And you
you
don't
know,
think that's just because they have observers on them? You think it's because they disproportionately do
yeah,
encounter these
yeah,
things?
yeah. I don't think it's just because they have observers on it. I think it's uh, because, like, take for example the 2004 incident, right? The craft were not near the strike force.
Hmm.
They detected them on radar, and the F-18s that they sent, they went out 50 miles to go find these objects because they could detect them on radar at 50 miles distant.
Oh, interesting.
And so we send two F-18s. They go to where the Princeton's radar says this contact is, and yes, right there they see a visual object. So I mean, what are the odds that your radar system just happens to pick up an object at 50 miles, and your jets go out there, and sure enough, there's a physical object? I mean, I don't know what more proof someone needs to know that that was not an, you know, pilots imagining what they saw. I mean,
Sure, yeah.
they saw something that a radar system told them existed there.
So the radar would have had to have been spoofed in some way, some glitch or
Oh,
weird
yeah,
density or something would have had to ping
yeah.
the radar. They would have had to go there and then
You'd have to
misapprehend something.
spoof the radar, and then you'd have to have some type of holograms to fake out the pilots who are so, you know, sure that that's an actual object that they go engage it, right? I mean, that's a heck of a lot of technology
Yeah.
uh, to
So I
try
guess
to
on
do
any
that.
account, so even if it was spoofed, it's some sort of technology we don't understand. It's not just a flock of seagulls or something.
Yeah,
Did you have
right.
favorite cases from this study that you wanted
Um,
to talk about?
yeah, I think of the my favorite cases, that were in this study is the Tic Tac case from
Hmm.
2004. Right, that's definitely one of my favorites. October 1968, a B-52 at a Minot Air Force Base encounters UAP, and it's detected by the B-52 radar system, right? And it's seen by all the pilots. And my favorite part of that whole story is that one of the there's like 6 or 7 guys on a B-52. So one of the guys is, they say, "Hey, come up and take a look at this UFO." And he's like, "No, I don't want to see it." I said, "What's wrong? Come and take a look at it." He said, "I've got a interview with Boeing next week for a pilot job, and I don't want to see any UFO."
That's hilarious.
And
Did he not look
yeah,
at it?
that one of the guys, and there's I know the guy who interviewed all the men on the B-52, and that that all of them saw it except that one guy, and that's why he didn't want to look at it, because he didn't want it to affect his getting this job at Boeing
Did
next
he get the
week.
job?
I don't know. I don't know if he did or not.
I hope.
I guess he did.
I
I
guess I
assume
hope
he
he
was
did. I don't
retiring,
know.
from
Wow.
the Air Force, and so that one's one of my favorite cases. Another one, this happened in the mid '70s over Ohio. It was Army reservists who were taking a helicopter back, uh, and there were 3 or 4 guys on the plane. I mean, the helicopter. They're headed back. They see a light heading towards them. The colonel, who was like not flying the helicopter, takes over the controls
Hmm.
because they feel like there's some aircraft and they're in danger of having a head-on collision because this light's rapidly approaching him. So he dives. He begins to drop down, and then all of a sudden, instead of that light that was moving towards him, there's this giant cylindrical object that's just right in front of their helicopter,
Hmm.
and it's sitting there and it's bathing them in green light. And I mean, and the magnetic compass on their helicopter starts spinning, um, and they're just sitting looking at this object, that's suddenly right in front of them. Well, for one thing, to go from being a light far away headed towards you to suddenly an object right in front of you, that's enormous acceleration. And it stopped, right? It moves suddenly, stops in front of them. And so it's one of these cases that wasn't Venus in front of them. That wasn't a
No,
balloon in
it
front of
was
them.
not Venus. Yeah.
Either these guys decided to tell a whopper of a lie, or it really happened. It's one of the two. I mean,
Yeah.
it's not like you can say, "Oh, they mistook Jupiter for a giant craft in front of
Enormous
them."
green glowing cylinder. Yeah,
Yeah,
what are the incentives? I mean, I think about people, especially people in the military, the incentives not to ever talk about this are so high that you have to assume they psychologically something is motivating them against their own professional interests to talk about these things. Even pilots in the, in the civil, what do you call it? In commercial airlines have the same,
FAA.
yeah, they
Or
have the
yeah,
same incentives. You could lose your flight status if they think that you're, psychologically unfit or something. So it has to be some real experience, and the effects that it has on people seem often really profound. Like, it kind of changes them because they don't know what they've
yeah.
experienced.
And there's actually, and again, I can't prove this and I'm not a psychologist, but there seems to be a certain amount of PTSD that
Mm.
affects some people when this happens, because not only is your worldview shaken up, right? But you can't really go talk about it. One of the
Mhm.
nice things for us as humans is when you have an experience that's, you know, tragic or horrible or what have you, you can talk to someone, and that's how you release. Well, because of the stigma and the way people think, if you try to talk about something like that, it almost forces certain people just to keep it in, and
Mhm.
that just makes the problem worse for them.
It makes me think of Matthew Roberts, who I know he was the cryptologist on, or one of the cryptologists on the Princeton during the Nimitz encounter. And he said he spent, after initially, they saw the video and the radar data and things, that he spent like every day, every free hour in the skiff just watching these videos over and over and over, because it just kind of broke some part of his brain, that he was seeing something
Yeah,
that had no, just did not fit with his conception of reality. And it became pretty profound for him, I think.
yeah, and I've always wondered about that, Michael, if it happened to me, because I've never seen an object up close that or evidence that was incontrovertible, right? How would I react? I mean, even though I've been studying the subject for 17 years, could I say, "Oh, yeah, I'll just take notes here," or would it affect me like that? I don't know, because I've never been in that situation.
Yeah. I know in some cases I find it frustrating that people are like, I didn't take out my camera or whatever when they saw this thing. But I think that I might react similarly, because there has to be some stunning effect when you see something that your brain just doesn't know how to process. You can, like, I can imagine just fixating on it and not understanding or knowing what to do. How do you respond to something that seems impossible or wildly new? You would get away.
Yeah. Yep. And I've thought about that too. And I think that's because that's your first reaction is, uh, can we come up with a rational explanation?
Hmm.
And your brain starts working on that rational explanation.
Do you have a little bit of that when you're looking at, I think you must, when you're looking at data like this? Like, isn't that part of the allure? Is that you look at this and you think, what can this possibly, can't be real?
Yeah. It's kind of like, yeah, how can that be?
But for now, this is good. Thank you for taking your evening and devoting it to this. I appreciate it.
Yeah. Thanks, Michael.
Yep. The Anomalous Review is a project of the Scientific Coalition for UAP Studies. It's hosted and produced by me, Michael Glosson, and edited by Kelly Michelle. Our theme song was written and performed by Telma Crisanti. Communication and PR work is by Preston Dykes. Our advisory team includes Jennifer Roach, Robert Powell, Richard Hoffman, Joshua Pearson, and Larry Hancock. To find out more about SCU, check out explorescu.org.